Question number 76. We have a word problem. Notice we're allowed to use our calculator for this problem. First thing that we're going to have to do is we're going to have to put our data into the data table so that we can view it in a plot. To do this, hit the Stat button on your calculator. It's just to the left of your arrow keys. Then number 1, or enter for edit. You're going to get some lists. We're going to put this X data in L1 and our Y data in L2. You'll only have 4 values in each column. The next thing that we might want to do is to view this data in a plot. What you'll need to do is hit the buttons second and Y equals. This gets into stat plot, which then you just need to hit enter to turn it on. What you'll want to do is highlight the first box in the next row that looks like a scatter plot. After you've done that, just hit the graph button. Unfortunately, because this is real-world data, it doesn't show up on our standard window, so we'll need to change the window if you haven't done that already. An appropriate window might be a minimum Y value of -100. This is just so that we'll have room below the graph so that we can easily find our x-intercept. And a Y maximum of +500. I chose 500 because the heights given in the table went up to 436. Viewing the data now in the stat plot, you see something that looks like this. Our data looks quadratic. A quadratic model from experience is the perfect model for this type of problem, where we know something that goes up must come down. After we put this data in our calculator, we're going to try to run a quadratic regression to get an equation that fits the model. To do that, start again with Stat. Move your cursor over to Calc in the top of the screen. And then choose number 5 for quadratic regression. Hit enter, and it should give you the equation that we'll write as h of t equals -16 t squared plus 50t plus 400. Of course, your calculator uses x's and y's, but we're going to use t for time and h for height. Once you have this equation, you can now go type it into y equals. And then we'll be able to solve the other parts of the problem. How high is the ball after 4 seconds? Of course, we could just plug 4 in for t in our equation and calculate y. Or you can look it up in the data table. Or use second trace number 1 value. And when it asks for x, put in 4. The answer that you'll get in return is 344 feet. Part C asks when the ball hits the ground. Remember, when the ball hits the ground, the height of our equation, or the height of our ball, is 0. Notice that that's the same as an x-intercept or a 0 on our graph. In order to find that, we will use second trace number 2, 0, and we give it a left bound and a right bound. And then hit enter one more time. You should get the value 6.801, which means that it takes 6.801 seconds for the ball to come back down and hit the ground. This solves number 76.